Good afternoon, students.
Afternoon,
Or
Mr.
good
Clark.
evening. Actually, it's evening now.
Yeah.
Yeah. Only just sliding and don't to say order to teach us, so I don't understand.
Sir, my day at work, me a plot a chart, me just busy.
No.
But I try to make sure to be on time, same way.
Yeah. Okay. All right. Cool. Aisha, how you stay?
I'm sorry, I'm good.
Good. Good. All right. We are going to we're going to begin in a few. I just want to mm, just review one or two of the things that we've done, and then see if we can just compound it by doing some standard deviation calculation and some variance. So I want to add on to what it is that we are want to add on to what it is that we are doing or we have done.
Yes, sir.
So let us see how best we can.
Evening, sir.
Hey, wait up, Papa.
Good so far.
Nice. Alrighty. We just all right. I think we should get the ball going. I think we should get the ball going.
Mr. Clark, man.
And I want us to.
Hello?
What's up?
Mhm. I'm
I'm
gonna
gonna
have
say,
to call her back because when I
oh,
spoke to her, I was doing something
mute,
else.
mute, 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 mute. Hold on.
Oh, sorry.
Mute. Next thing we hear him love stories. Hey. All right. All right. Sorry. So that's that. All right. So tonight is not going to be. It's not going to be a hard one. I just want to. I want to extend our table that we have been using. So I pray that you are in the best of health and ready to go. We have, well, 15 minutes have gone out of our session. And I was about to say one other person has joined, but Mikey changed his device. So let us see how best we can. Let's see how best we can. Flex a little bit of muscle. So today I was invited to a class to help with some SBAs, and I I was having a conversation with some students about the practicability of the mathematics that we're doing. Now, some of you here may be saying to yourselves, why am I doing such a program, but yet still I have to go through with this environmental statistics and I don't like it, support and so on. I'm going to say to you, I don't want any of you to think that way. As an environmentalist, you will always have to collect samples, you'll always have to work with data, and you should be able to be in a position to represent that data and to speak on the data that you've gathered. These formulations are just a way of explaining the data in a simplified manner. The data collected, it means nothing in its raw sense. It's like food. You have the raw food, you know, and you can see what possibilities can come out of it. Now, the truth is, I may have the same ingredients and the same type of food. I may have a master chef competing against me, or sorry, I am competing against a master chef, and we're using the same ingredients, we're using the same proportion, but his touch or her touch will definitely be different from mine. So clearly the food is going to taste different. It's going to look different as well, right? So each person comes to the table with a different style of presenting the information and presenting the data, and the reporting of such a data. But it is important that you find a method to communicate to those who are receiving the information in a manner that it now become usable. Because if you're presenting the data in a manner that them can't interpret and them don't know what it means, it don't mean nothing, right? But and communication would not have taken place because there would have been a barrier. So when you're communicating your findings, the person to whom you're communicating should understand what it is that you're saying, so you have that two-way flow. All right. What is also important is, say, for example, Asia may be able to find the variance or the standard deviation of the student's performance in fourth form. She is not necessarily reporting directly to the principal. She may, however, report to the administrator of the institution. Now, the administrator's responsibility is to communicate that to the principal. And then now the principal now will be responsible to communicate that to the chairman of the school board, so that when they're talking about the stuff, they can get X, Y, Z. So Asia has to be able to communicate effectively so that the administrator understands what she's saying, and then the administrator will have to communicate effectively so that the principal gets exactly what Asia initially told the administrator. Anybody ever play Chinese telephone yet?
Yes, sir.
You know what Chinese telephone is?
Yes, sir.
Didi, is that a yes or a no?
Yes, yes, sir.
Oh, you said yes. So D, tell me what happened in Chinese telephone.
You pass around a message.
And what normally happens?
Message can get mixed up.
Distorted, bad, don't.
Yes.
So I may be communicating. My initial message may be standard deviation, and by the time I reach the end of the line, it reach I love you. Totally different, far from the truth, right? And kill me dead at that to tell me, because so you know, people embellish a story. Look at Cliff Twang. Nobody can cross it. Only who understand it can cross it, right? No, it sounds good and his reporting sounds nice and people want to hear it, but when you say nobody can cross it, only who understand it can cross it. Others can cross it, but you know, when you say nobody, it means that it's only a certain set of people and you have a certain set of skills, you know. But really and truly, others can get across it. All right. What's the point? The point is we are going to be looking at some other types of calculations tonight, which is going to be compounding what it is that we would have done in the other calculations before. And we should be able to be in a position to communicate those findings in a manner that will be acceptable by or understood by the recipient. Now, when we're looking at our grouped data, we normally talk about our class intervals, we normally talk about our frequency, we normally talk about our midpoint, and we normally talk about our F times X. So the first 4 columns is what we normally use. True or false?
True.
Yeah, man. So if the data is already given as grouped, this is what we use the first 4.
Yeah, I was just going to say we might have 5 if we have to tally it ourselves.
Very good. Excellent. So if the data is ungrouped and we have to do our tallying, where would the tally go?
Right after class, between class and frequency.
Excellent. Excellent. Right? So we do our we do the table like that so that when we do our multiplication, it is easier. So when we have our class interval, we do the tally. And after we do the tally, we're going to write our frequency. No, the same value that is in the tally is going to be in the frequency, but we're just moving the tally now to numbers. So we go 1, 2, 3, 4, cross it to get 5. 1, 2, 3, 4, cross it to get 5. You know, a cashier or a teller, well, not teller, but a cashier, when the person is, you know, trying to balance off, at the end of the day, they start counting the money into, some of them count it into 1,000. Some of them may count it into 5,000. Some of them may count it into 2,000. So that when, at the end of the day, you know, when they're checking up, they know they already have the money sorted in a manner that it is easier to count because they've already stashed up in 5,000, 1,000. So they may use the $100 and batch the $100 in thousands. They may use the $1,000 and batch it in 10,000. And they may also batch the $2,000 in 10,000, the $5,000 in 10,000, right? Whatever method works for them, they will do it. So we have the first 4 columns. Now, when we're moving to variance and standard deviation, we now need to have something that is going to be the frequency times x squared. So here we're going to square our midpoint and then times it by the frequency. We're squaring the midpoint. See, f x squared. We know what f is, the frequency. We know what x is, the midpoint. So we're squaring the midpoint and times it by the frequency. That goes in this column. In this here column, we are going to be saying x minus x bar. But x bar, remember x bar, what is x bar again? Say the last. No, x bar. X is
frequency.
Say it again.
I was asking if it's the frequency.
No, but the frequency is f. Remember when we're doing the first calculation we did last.
I have something, sir. I don't know where to turn him.
The first calculation we did last class. What were we calculating?
Oh, the mean.
The mean. So the mean of the data, we normally write it as x bar. All right? We normally write it as x bar. Now, as we go along, we have things that we call sample mean and the population mean. So every time I think about it, I laugh. With them name, starting the failed census for this time around, billions of dollars were spent and we still don't have a census. We don't know what is what. To date, I've not heard of anyone who told me, any of my friends who told me that they were visited by one of those reps to come and do the stuff. We don't know. When we're calculating the population mean, we use one thing, but when we're calculating a sample mean, we use another. So we have a symbol for the population mean, we have a symbol for the sample mean. Sir, why the difference? So when Statin is doing the mean of whatever data, because they're referencing population, they're going to use one thing. Now, if we are doing something, for example, when Don Anderson is taking a little poll and he says, the poll is representative of the population, and he says that he is using only a sample. his formulation is going to differ slightly because he's only maybe using persons from St. Elizabeth as a representation of Jamaica. So that is only a sample of the population. So we have something that is called a population mean, and we have something that is, well, we have something that is called the population variance or standard deviation too, right? We also have something that's called the population mean. And, you know, so it depends on what it is that we're doing. If we are doing the sample versus the whole population, all right? And it is easy to find out which of them we're working with. Easy to find out which of them we're working with. All right. So it's going to be x minus x bar. X minus x bar. So what we're doing, x is the midpoint. We're using the midpoint and we're subtracting the mean from it. All of this here is going to be squared to get x minus x bar all squared. X minus x bar all squared. And then all of this, I'm going to multiply by the frequency. So you see, the table in and of itself is connected. So we know the first four. And if there is any sorting that we have to do, tallying we have to do, we'll get a fifth one in there. Then we're going to find x squared times the frequency. Then we're going to say x minus x bar. Then the same x minus x bar, the same values that you get here, you're going to square the value here to get here. You're going to square this value to get it inside here. And then when you finish all of that now, the value that you get right here, you're going to multiply it by f to put it over here so you can complete your table. So you're doing your table in stages. You're doing your table in stages. Now, what does this sign mean?
Sum.
The summation sign. Very good. And you should, very good. And you should all know this because you got summation in pre-calculus, right? So what we're going to be doing now is summing all of my frequency times my x minus x bar all squared to get this value, right? When I get that value now, what I'm going to be doing, and I just explain what is happening because we're going to go back to that question we did last time around. So it is that we can just play around with some variance and standard deviation. So if you recognize for my variance is this very value here, which is here, and then I'm going to have 1 over n. What is n? Remember, n is the number of, what is n?
The total of frequency?
The total of the frequency. Very good. So we're just going to divide that by the total of the frequency to give me my variance. And then my standard deviation is when I take the square root. You recognize that all of this is the same thing as this. I just take the square root of this. I take the square root of that. Does that make any sense? I will send you this document. You can look at it. I can send it off to you. But what I want you to do for me, is, I don't know if I can find new share. All right, so there is a mosquito in here that is annoying the crap out of me. All right, don't know if, let me just do this briefly. So based on what it is that we did last time around, we did a mean of the number of days, we did a modal time, but they also asked us to calculate the standard deviation. They also asked us to calculate the standard deviation. All right. So we're not even going into the interpretation of what the standard deviation is just yet enough. We just want to be able to get to understand how to go about the calculation, and then we can do our interpretations thereafter. So just reminding you, we had a group, we had our frequency, we had our midpoint, we had our f times x. What I want you to do for me now is this data that you have inside here, I want you to be able now to complete the table, so that can you see that? Are you seeing that screen?
With
Yes.
the plus?
The one with the variance and standard deviation up top, the table that I was just showing you a while ago.
Yep.
All right, good. So that you can get the remainder of this table here. So, oh Lord, how am I going to do this now? You may need to take a screenshot of this. take a screenshot of this table. Take a screenshot of what is on the screen just now. Take a screenshot of this for me. And then, because I'm going to ask you now to complete this table, I want to see that you are able to complete the table, and then we can play around with the formulation for the variance and the standard deviation. Fair enough? Talk to me. Understand what is it that I'm asking you to do?
Yes,
Yes, sir.
All right, good. So that is that.
Yes, sir.
So have you taken the shot of this?
Yes, sir.
Okay. Strange. I'm looking for my cell phone and I can't find it, and I hear a message. Somebody just sent something in the WhatsApp group? No? Okay.
No.
I just hear the phone go off, and I was looking for it earlier and I couldn't find it, but anyhow, and at least I know that it's around me. All right. So take a screenshot of this. Then what I want you to do is to go back to what it is that we had from before. Can't find it now, but anyhow, what it is that we had from before, and complete the table for me, please. Let me just do this so I can find where I'm at. I'm hoping that my instructions are clear. Am I clear? You understand what I'm asking you to do?
You're asking us to
Yeah.
complete the table.
To complete the table. All right, good. So can you go ahead and complete the table for me, please, and thanks? I am going to be doing it as well so that we can compare our stuff to make sure that we're understanding exactly what we're doing, and we're going to look at the figures. All right? Quick and fast. Thank you very much. I give you 5 minutes. Make sure you have a calculator and start working. All right.
Sure, quick question. So if x squared would be x squared times the value of f.
Very good. So
Okay.
f x squared, you're going to square the midpoint and times it by the frequency.
The midpoint or the mean.
X is the midpoint.
X is the midpoint. So when you go over to x minus x.
X bar,
Yeah.
it's going to be the midpoint minus the mean.
Oh. Okay. All right, got
Cool.
you.
Sorry, you said the X bar is the frequency? Uh,
Talk a lot about it.
Mm.
I'm asking if the X bar is the frequency.
Mm-mm. The mean. That's the mean.
And the X would be the midpoint.
Yeah. So it's the midpoint minus the mean.
Oh, okay, all right. Then,
The frequency is F. So we have to get with the notations. So we know exactly what is what. But yeah, continue.
I say a quick question before we continue. The first X is the mean or the second X? Because that will determine
The
if the answer
midpoint, my
positive or negative. Eh?
The first X is the midpoint. The second one with the bar over it is the mean.
Is the mean or
What's your I'm asking you a question and I reflect. I was about to say why you're not answering me, but I was muted. I know why the questions are coming in because you are getting some negative values and you're wondering if you're correct, true or false.
Yes, sir.
true, true, true.
No, but no. I know Uno all too well. But yeah,
So
man, you're good, man.
I
Continue.
get
Continue
some big
working.
number, I may get some negative number, I may say this can't right.
Yeah, man. Go on to the stuff, man. Go on work. Paz. You have to be a part of this, you know, Paz. Asia. Asia.
Sorry, sir. I'm just so consumed with work tonight, sir. Honestly, like I'm getting a lot of calls. I'm up and down. I
I
can handle a
understand.
lot of stuff.
Yeah, but it's I don't want you miss this, you know, because this is the exciting part and the part where you come for your mid semester and go dip on the final exam again. I'm want you put mash it up and I want no C9 or sir or something like so. So anyhow, do what you need to do. Lend me an ear. How far reach? Hmm? Hello, somebody.
Sir?
How far reach? Finish the table?
2-1.
Okay.
All right, so sir,
Mhm.
it would have easier if we just multiply the f by the square the x minus x square, right? Instead of work over out of that.
I'm not following what you're asking.
All right, the let's see now. 1, 2, 3, 4, 5, 6, 7. It's easier to just multiply f by the seventh column. The last two columns.
Yeah, we put
Oh,
the X by the, I want to check something here. Yeah, that's what you're doing. Yeah, but you see, we do it in stages though. Because we say X minus X bar all squared, and then that value they multiply by F.
okay, all right,
Yeah,
good.
but I want you to write down the value for X minus X bar all squared though.
Yeah,
So
man,
it's easier for,
we just
yeah.
complete that one then.
Yeah, so the answer to your thing is yes. Let me know when you guys are.
Yes, sir.
Obviously,
Almost.
almost.
Yes, sir. Almost finished.
Is Asia back? Asia, you back?
No, sir, she's not back.
Right. Um, obviously. Ouch.
All right, sir. Ready.
Um, Dan, how you stay?
For me?
Mm-hmm.
Yeah, I'm ready.
Oh, you did ready long time? I never know. Oh, and pass him working. All right. Now, I don't want to project my answers just yet. So, pass is just Yan Dan because Asia is gone and pass is somewhat engaged. I doubt he's doing the calculation. So tell me, did you take the sum of f times x squared?
Yes.
What you got?
No, sir. We never sum up anything.
All right. Okay. That's fine. That's fine. What you got for the first column?
36.
First column.
36.
Mm-hmm.
Next.
2,187.
What?
I mean, want ask the same question to Dan. Where you get Dan?
729, sir. It would have been 3 times 20. Wait. Or let me do it wrong.
What are you supposed to do? X squared times F.
Exactly.
How that much?
So what is X squared? The 36 is correct,
Right, wrong. I was looking at the wrong
and that's why
table.
I'm doing this. That's why I'm doing this exercise with you, because this exercise is, you have to be very careful with picking up the correct value, or else you're gonna go wrong. And when you come out to the exam and say, yes, I'm good, and you're not good. So that's why I'm not projecting my screen just yet. So let's go again. So fx squared, f times x squared, the frequency times the midpoint square, is the first column is 36. All agreed?
Yeah, yes, sir.
What's the second value? 8 to 10 mid-class interval.
Twenty, not 27, 729.
Why you got 729?
Because I said the f of x and I square it, it would be, wouldn't it be 27 times 27?
No. That's the problem. Problem is, you can't say it is not f times x all squared. It is x squared times f. You know what I want you to do? I want you to write it just like that.
Put it in bracket. So it's X.
No, what I want you to do is to write the x squared in front, so that you don't think that it's going to be fx squared. Put x squared times f. Put x, because I don't want you to think that is fx all squared. So what I want you to do, I want you to put x squared in front times f. So it is not the 27 that you are squaring. It appears as if that's what we did to get the 36. But what we're doing, we're squaring the x. 9 nines 81, and 81 times 3 gives us 243.
Sir, all of mine wrong then from the song.
Yeah, and that's why I'm doing what it is that I'm doing, you know.
It
It's
just
very
makes
important.
sense.
And that's why I'm going through this. I mean, at the expense of moving slow. I was talking to Sir Walter today, and I said, say it again, Dan.
Sir, all of this wrong.
Yeah, everything wrong from everything. We're not even want to call a next number. Because
No,
that's
but
we get some big number and it doesn't look right.
and that's why I'm giving you the exercise to do, because I want to make sure that you guys are getting it. So guess what? We're gonna go back at it. Just drop a next column. You don't have to erase everything. Just drop a next column, even underneath it. It is. I want you to write in the top part. So we have the class interval. We have the frequency. We know the frequency is f. We know the midpoint is x. We know that it's going to be. I don't want you to write fx, because when you write fx, it looks like I don't want you to get confused. So we're going to write x first, and then the f after, because I don't want you to get confused.
Only column would have probably, wait. I don't think none of them wrong. I just, this one wrong, sir.
The other columns will be wrong. Well, no, not necessarily. Not necessarily. Yeah, not necessarily. Because, all right, let me ask you, what you got for x minus x bar for the first one?
Negative 7.68.
Yeah.
Second column.
Negative 4.68.
Then?
Yep.
Negative
1.68.
Then?
1.3832.
Next?
4.32.
Then?
7.32.
What is x minus x bar all squared now? You see all squared, you see the parenthesis in here now? There's no parenthesis in the other one. So what is x minus x bar? Incidentally, that column is correct. What is x minus x bar all squared?
Negative 151.14.
No, because
58.9824, sir.
That me get to 58.9824.
Sir, all of them end with 24. And the
Yeah,
first
all of them end with 24, yeah.
68 and the positive.
Oh, you get that. I get that.
Because you said all of this and you just square it.
Negative 7.68 squared.
Squared, right.
What is the second column, Dan?
21.9024.
Then
2.8224.
next,
No, my dear.
1.7424.
next,
18.6624.
then.
53.5824.
All right. What is Mikey, I want to make a correction. And then no, that's correct. And then no, f times x minus x bar all squared is
The first one is 53.5824.
how?
So I was wondering the same thing to when I entered it in the calculator.
And I think that's the same thing that Mikey is doing. Because remember, the frequency in for the first one is 1, So it means
Yeah.
it
So
means
it
it's supposed to
should
be
be
the
the
same
same, but I don't
58.9824.
know. So I don't know. That's what the calculator gives me.
All right, I'm going to tell you what is happening. What do you get for the second one?
65.7072.
Next.
25.4016.
Uh-huh.
12, wait a minute. Oh, 12.1968.
Then
55.9872.
then
107.1648.
no ma'am.
All of them is wrong?
No, you tell me, read that last one for me again. You said 100, you said 107.
Yeah.
Calculate
0.1648.
107.
Well, sir, remember the frequency is 2, and wouldn't it be the 53.5824 times 2?
Yeah.
Wait,
You
let
do
me
that calculation for
see.
me.
It said that's right that the calculator said.
Okay. Yeah. So I had a digit wrong. You're correct. That's why I said no, ma'am. So I had a digit wrong.
Oh,
So you see, even me can make mistakes. So it's 107 1.1648.
yeah.
All right. So I got one of them wrong. Fix the
You
first
get
one for me,
knocked
please.
down.
Sir, so what is the first one then?
58.9824.
58.982. So, sir, is it that the calculator is wrong?
So what happened with the calculator is that before you started the calculator was not cleared. So it had a value inside there before, and it used that value to multiply the 58.9824 to give it that incorrect
Oh, I
value.
get it now.
Yeah,
So,
that me realize me I do that as well.
Yeah, man. So that's what you were doing, Mikey, to get those values off.
Mhm.
and then the total would be 320. No, it can't be 320 then.
Oh, yeah, my total would be wrong because I had one. Yeah, my total would have been wrong. So let me just go ahead and do that. 1295.44. I had 1077.1648 equal plus 107.1648.
So, sir,
Oh, yes,
make
Papa.
it correct. Oh, all right. May I make some notes as well?
So this is just a working exercise because I want you guys to
325, not 320.
325 point
04.
04. When is 04 me get? I'm checking it back over. I get 325 point something.
What is something, sir?
Let me check it before me tell you so you don't laugh after me. I get 0.44.
Michael, you check it? You have to.
Check it, but the calculator start malfunction.
Yeah, I get 325.44. You check yours again, Dan,
Yes,
please.
sir. I'm going to check it again.
If you had not calculator, my first world country, that's a good side. So 0. So I'm gonna do it that way. Yeah. What the hell? Also, X, where,
I get the same thing, so I'm not sure now.
36. Let me see if it does work. The second one, you get to 243 for f x square. Yeah. And oh, Miss Francis ever see me I do this at madness?
Matter of fact, I'm going to call her and tell her.
They beat me because she show me how to use the calculator.
I'm going to call her and tell her. So that's confirmed. Dan, I'm a little concerned that you got all the values for the last column, but you're not getting the 0.44.
No, I just read it and I got the same 0.4, so I'm not sure.
Just double check. Let me call the values and tell me if you get that. 58.9824.
Oh, you have 9824. I had 5824. That's no problem.
Just double check that for me. X minus X bar. The mean is 13.68.
Wait, no, sir. I'm saying for the last column, the first one I have 58.5824.
No man, I get that.
Should have been 9824.
So it's supposed to be 9824. That's what.
Yeah, you're correct. It's on my end.
Okay. All right. So let us just agree on the table here. So you notice what I want you to start doing for me now. I want you to write x first, xf, and x squared f. I don't want to put the x in front of it because I don't want to make that mistake again. Agreed?
Yes, so we should put the what?
Look up here. You see, I have the x first. Let me see if I can.
Yeah.
Yeah. I don't want to make that mistake. So I put my x first, and then my x squared first.
Okay. Yeah, that make it easier.
No.
Read.
If you do get a question like this, chances are it is going to be a question for, well, this one was 3 marks, 4 marks, 4 marks, that's 11 marks. And then the variance and standard deviation was another 4 marks. That's what it was. It's about 15 marks, you know. So you can get a question like this for 15 marks and then get another piece of question for another 15 marks to give you 30 marks. So you don't want to go in there and make a mistake with this question. You want to go in there, double check your calculations, make sure you say everything right with the column, you extract the information, and you're good to go. Fair enough?
Yes, sir.
Yes, sir.
So I want you to be able to utilize the column. Take the time when you get the stuff, when you fill out the column, to go back again and double check your column, the entries. I made a mistake. I typed 1077.1468. So when Dan told me 107, I was like, no, ma'am. And then when I look at it, I was like, oh crap, but 53 times 2, not going to give me 1,000, going to give me 100. So I recognize that I typed an extra 7. Because mistakes can happen. Mistakes can happen. So just make sure that when you put in the stuff, you get that. Now, what I want you to do is to, all right, so you recognize that we would have added our frequency. Now that both of you are at the same page. You recognize that from the first part of the question, we would have added the sum of our frequency, don't it?
Yes, sir.
All right. And then now, would have also added the 342, because to get the sum of the exams F, because that's what we added. 342 is what we divide by the 25 to get our 13.68, which is the mean. Talk truth.
Yes, sir.
Yes, sir.
Good. Then now, our x squared or midpoint squared times f, we're going to sum that as well. Sum that and confirm that you get 5004 P's.
Midpoint times F.
Midpoint squared times f.
Yes, sir. I got the same.
Hold on, repeat that, sir. I'm not follow right there, sir.
This piece. Midpoint squared times f. The same column that you just fixed a while ago, man, with the 36 and the 243.
Yeah.
Add up those and tell me if you get 5004.
Oh.
So that's the midpoint squared times f.
Five, four, okay. Hold on. I get that. Yeah, sure, sir.
You got 36 and 243 and 12, 96 and 50.
Yeah.
Add it up again, man. Clear the calculator. Your calculator is storing some data. Clear it.
Sir, my 1,000 shot. I don't know why I keep on I get 1,000 shot.
Read the values for me.
My values? 36, 2, 4, 3, 1296, 1575, 972, 882.
Turn the calculator off. Turn it back on. Which calculator are you using?
One of the Chinese Casio them.
Join us. That's it.
No man, SVDAL. So what that one mean?
Like seriously?
Antigua.
And I get the same.
A man of your caliber is using that calculator?
Sir, I tell you, sir, we can't
Just
find
use your
no
phone
other
or mic
calculator.
or your laptop.
Mikey, I don't know what is happening. And I don't want to go into example use a calculator neither.
No,
So
man,
use another device and calculate that for me. Dan, you get the 5004 down.
Yes, sir. I did it again and I got the same.
Me too. So come back. We're waiting on you.
oh my. All right, man, I use that calculator.
What you get now?
5,004.
All right, good. All right. So you still see my screen, right?
Yeah, man.
All right, good. And I want you to understand what we're doing right here, because there's one time you need to see it. And that's why I'm spending time so that you can get your column. So you see all of this up here, so you need to know it. 1, 2, 3, 4, 5, 6, 7, 8. And if you're doing a tally, you're going to end up with 9. This column, this table alone gives you quite a number of marks. Because to calculate the mean, it's going to be your x times f divided by your f. So this division gives you your mean. Watch how I'm going to get my variance. You see the sum of this column here, 325.44. I'm going to divide this by my f. And that should give me my variance. This 325.44 divided by 25 should give me my variance. Do that division for me, please, and tell me what to get.
So the 3.44 divided by 25,
Yes, ma'am.
13.0176.
And that's what I got, 13.0176, and that's your variance. Was the variance difficult to calculate?
Do that one more time, sir.
No, you can do it. 32544 divided by 25.
Oh.
Do that and let me know if you get it, please. Don't use that calculator.
No, man, I use the one for the Mac. Divide by 24. 25. Divide by 25. Correct, sir?
Yes, sir.
13.01.
Yes, 13.0176.
Yeah, that's it. Yeah.
All right. Now, that is your variance. Take the square root of that for me, please. Take the square root of that for me, please. And tell me what you get.
$13.0176.
Yeah, the 13.0176. Take the square root of 13.0176 and tell me what you get. What answer you get?
3.607991131.
Yep, same.
Correct to the T. And that is going to be your standard deviation. So you see what is happening. So the 13.0176 is my variance. I take the square root of that. If you look carefully, see, I'm taking the square root of that to give you my standard deviation. I'm taking the square root of that to give my standard deviation. Now, tell me, yes, it's a lot of calculation, and most of the work is done in the table. So spend the time in the table and see, it's the sum of my f times x minus x bar all squared divided by the number of terms. See here? The formulation says the sum of f times x minus x bar all squared. And I'm summing it. You know this summation from pre-calculus. I starting from 1 down to n. N is the number of terms. Any number of terms we're talking about, but this one here is 25. That one is 25. So what I've done is to sum all my terms from 1 to 25, and then I'm going to divide by that. So it's going to be frequency times x minus x bar all squared, and I'm going to multiply it by 1 over n, or simply just divide it by n. Then I get my 13.0176. And then to get my standard deviation, I'm going to square root it. And I'm going to get my 3.6 3.61. Do me a favor. Try this in the calculator and tell me if you get it as well. Clear your calculator for me, please. Clear your calculator for me. Do 5,004. 5,004 divided by 25 equal minus 13.68 squared, and tell me what you get.
$13.0176.
Is that the same answer we got from before?
Yes, sir.
All right, good.
So
So
we
that's
what
another,
a while ago, 5,004. Say what again?
it's the 5,004 divided by 25
Okay, minus the 13.
Minus the square root of the mean.
minus a mean squared.
Yeah, the square.
Right.
Oh,
The mean squared, 13.06 squared, right? So that's another method of doing it. Truth be told, though, I prefer the first method that I've shown you, because at least you know you can do, you see the values in front of you. You can do it that way. You get it out. But guess what? You see, when you do your answer that way, that other method that I just showed a while ago, the x times the x squared times f, the sum of the x squared times f divided by the frequency minus the mean squares, you should end up getting the same answer. So if you do the calculation and don't get that, boom, you know, for something right. So you can use that as a quick check to see that you're correct. All right. And then when you square root that, you can get your 3.61. And your 3.61 there is going to be your standard deviation. Tell me, do you think you understand what is happening in this table here? All right. What I want you to do for me for homework, as we're ending, what I want you to do for homework for me, there was another question. I think this was the second question. There's another question that we did. Don't remember that question. I have to go look for it. The one that we had for the tally. You remember that one, guys? Well, I don't think you were here, Dan. Were you here, Dan? I know Michael was here.
Sir, the formula that they just give us, the sum of x squared f divided by the sum of f minus the square root of the mean.
No. Minus the mean squared.
Minus
the mean squared.
Yeah. It's equal to what? The variance or standard deviation?
The variance.
Variance.
So there's another question like this that we did, but we never went as far. We only did the mean, the mode, the median.
Oh, but you never showed the other part.
Right. So now that you know how to do the variance and the standard deviation, I want you to go ahead now and extend the columns and to do the variance and the standard deviation. And God's willing, on Tuesday's class, on Tuesday, we can compare notes, like I'm comparing notes right here now, to see if we get the same answer. Oh, that's all.
Yeah, man.
I didn't wait.
We can send the question to you.
Right. Send the question. I doubt she was here, so you can send the question to her.
I only have the one with the class and the frequency and the
No more.
the arithmetic mean and the median.
It's all right. Mike will send the question to you. And when you work the question, I can extend the question to ask you to calculate the variance and the standard deviation. I didn't do that because at that point in time, I was only teaching you how to calculate the estimated mean, mode, and median. All right? So now I want you to calculate the variance and the standard deviation of that set of data for me. So now you should be able to do that full question. I don't know if you saw what I was doing. I broke up the question in pieces. Instead of giving it everything one shot, Now that you've digested to do the mean and the mode and the median, I am now giving you the standard, the variation and the standard deviation. So calculate the variance for me and the standard deviation of that first question we did. Then hopefully at the start of next class, so you can take that to class. So that's his homework. You're going to take that one to class. We're going to look at it pretty quickly. And then what I may do is then go back through those two questions, question 1 and question 2. Read the full question now, so it is that we can do the interpretation. Because remember, I said to you, I just want you to get the calculations out of the way. Now that we've got the calculations out of the way and we are all agreeing that we have the same answer for our calculations, what I want us to do is to go back to those two questions, do the interpretation of the questions that we got, and then now we're going to attempt one full question, and then I'll allow you to do the full analysis of the question. Sounds good? Sounds fair? I think it's reasonable?
Yes, sir.
And then now, hopefully, time would afford us to move into another area because I'm finished off with this area now.
Dowden, I sent it to you.
All right, guys. Big up on yourself. We'll talk.
Come on.
Take
Enjoy
care.
your weekend, sir.
You too, Papa. Take care, Didi.
Take care, bye.
Mm-hmm.